Hi everyone. Okay, so welcome back, and I hope you've had a good stab at the extending the chicken and egg model. So I'm going to talk you through the solution now. Just follow along. If you didn't manage to do it yourself, hopefully this will make sense as well. What we wanted to do, if we sort of go back to our slides, first thing we wanted to do is to capture the not all eggs that later will be fertilised, and we only want to capture fertilised eggs. So the first thing I did was just to rename my egg stock fertilised eggs because that's all we want to capture in our model. And we said that we want 80% of eggs by default to be fertilised, but we'll make that user definable parameter slider. So what I've done, I've added in a variable here called fertilisation rate, and I've set that value to be zero point 0.8, but I've also said show a value slider, so that allows me to here the user to be able to change that fertilization rate. Um, and I've linked that into the laying of eggs because the fertilization rate is now also going to determine the laying of eggs. So before we just had laying of eggs flow rate as being so the rate at which eggs come into being as being the number of chickens times the laying rate, which we said was 5. Here, though, that's not going to be the case because only 80% of them, or whatever the fertilization rate is, will come into being in our model because we're only capturing fertilized eggs. So I've changed this slightly. If I go into the flow rate, say chickens times laying rate times fertilization rate. So we've also got the fertilization rate that is playing a factor. So in this case, it'll be zero point 0.8 that will be zero point 0.8 of the chickens times the laying rate that will be coming in. Don't worry if you haven't got a separate variable for laying rate and you've just left that as times 5, that's absolutely fine. So you may have chickens times 5 times fertilization rate. That's equally correct. Okay, so that determines that bit. So now we're only getting fertilized eggs in our model. We now need to capture the fox aspect of things. So I've set up um, a new stock called foxes, and we said that we want initially we want 100 foxes in the model. So I've set up an initial value of 100. First thing we need to do is to model foxes coming into being. So I've got a flow coming in from nothingness to represent the birth of kits, and we said that a fox gives birth to around 5 kits per year. So if we go into this flow rate, so uh, if we just think of one fox at the moment, so one fox would give birth to 5 kits over the course of a year, which in system dynamic terms means that if we're running it in weeks, that means that each week it gives birth to 5/52ths of a fox per week. So that would be the case for so that over the course of the year, it's given birth to 52 over 52 foxes kits. Um, Sorry, no, I don't mean that. I mean 52 times 5 over 52. Um, so that's for one fox, but obviously we need to consider that there will be more kits born depending on the number of foxes. If we've got 2 foxes, for example, then over the course of a year, 10 kits are going to be born. So we need to multiply that 5 over 52 by the number of foxes. And you don't actually need to create a link here, although you can. Um, but remember, we said that flows already incorporate the thing they're flowing to and the thing they're flowing from, if anything, um, into things that you can use in that equation. They're already linked automatically, so I can automatically just times by foxes over here. So now we've got 100 foxes to start with and new foxes coming into being. We're also going to need to add a flow out of chickens into nothingness. You could, of course, have a flow into a stock of chickens who are dead. I just chose to have them cease to exist in the model, but either is fine. Um, and that flow out of chickens represents chickens being killed by foxes, and that's what I've called my flow up here. And the number of chickens that are killed by foxes um, in each week is going to be dependent on 2 things: the number of chickens that are killed by each fox each week, and the number of foxes. So those are the two things that we've linked in here. We've already got foxes, the stock level of foxes that I've linked into that flow rate. But we've also created a new variable called the number of chickens killed by each fox each week. And remember, we said that by default, one fox kills one chicken every 5 weeks, or to put it another way, every week they kill 20% of a chicken, so 0.2. So that's my default value, 0.2, but again I've selected to show a value slider so that users can change that value. And so I've linked that in. So now all I've got to do in my flow rate out of chickens into nothingness is to define that flow rate. And that's simply the number of chickens killed by each fox each week by 0.2 by default in our case, times by the number of foxes that'll apply per fox. And that simply becomes our equation. Because we've linked those things in, we can automatically grab those elements. So if I now run that model, like so, we can see by default we've got foxes, chickens and eggs modelled, but we can see the chicken population is still spiralling, the chicken and egg population is still spiralling out of control. So I added a new display here just so I could see this more clearly. So what I'm really interested in are the chickens and the foxes. So those are the two things. The blue line represents foxes, which are not growing at anywhere near the rate. They are growing very quickly, but they're not growing at anywhere near the rate of chickens, because chickens have got an exponential growth and foxes haven't. But we can see that foxes certainly aren't killing off chickens within a year. I've got this running for 5 years. 5 years? No, 7 years. And you can see that clearly the chicken population is still going very healthily. Little point, when you set up these new displays, you can click on them to turn them on and off. So if I just wanted to look at chickens, or if I just wanted to look at foxes, I can turn them off. So if I turn off chickens, you can see the graph will automatically rescale, and you can see there is an increase, but not at the same extent as there is for chickens. So clearly 0.2 isn't enough. So I could try changing that value of the number of chickens killed by each fox per week. So I'll put it too high. Let's try it as 0.5. So half a chicken killed per week, or in other words, a fox killing a chicken every 2 weeks. If I simulate that, still we've got our chicken population spiraling out of control. If I doubled that to 1, so each fox killing a chicken per week, and click simulate, and if I now look at my graph of chickens versus foxes, we can see the chickens have died out and the foxes continue to thrive. And if we have a look, if I add that display and look at on a table view, so if I look at chickens and foxes, we can see that chickens actually died out pretty quickly there. But is there a lower rate? And it turns out, as you may well have found, that if we put in a value of 0.91 for the number of chickens killed by each fox per week and simulate that, that appears to be the lowest number of chickens that are killed per foxes per week to exterminate the number of chickens within a year. And if we look at the table view, we can see it takes place after about 7 weeks. That chickens, so that they immediately get killed. Quite a few of them get killed very quickly, but then there's a sudden surge as a number of eggs hatch. But then they can't keep up. Foxes are killing too many of them, and so they die within 8 weeks of the model starting. So that should be the answer you found. Hopefully that was useful for you. Hopefully that made sense. If you do have any questions, please do let me know. Get in contact on Slack, or send me an email, or whatever. Ideally, contact me on Slack and post that publicly so that everybody can see it, so that we can. I expect many of you have similar questions. Beauty of things on Insight Maker, if you want me to have a look at anything, you can just send me the link to it. So if you click share, it'll come up. No, I don't think it does. Ignore that. So I think you can just click the link. So that's my particular URL for this model, and as long as it's been saved publicly, I should be able to then access that and have a look at that for you. So just share that link with me. Um, but I'd encourage you to check each other's out, share your links, have a play around with building other models as well in Insight Maker. And in our discussion, for the first discussion of the day on our webinar, we're going to kick things off before Sean takes over for the rest of the day and talks about network analysis. We're just going to kick off with a discussion around some of the applications you can see for system dynamics within policing. So let your imaginations run riot, and we'll be talking to you shortly.